Welcome to this feedback video of episodes 6 to 8. We've received 12 submissions so far. Thank you for that. Very nicely condensed bill of materials and some first results on linear scenarios that you've modeled. Some of you are still working hard to finalize episode number 2. So in that case, I hope this feedback video will help you to make a swift start with episode number 3. So what we'll address in this feedback video, we'll give a short overview of the work that you've submitted. We'll dive into several examples and address the questions or some of the questions that you've asked on the Miro board or on the discussion fora. So thank you for that. We have a very nice diversity of examples, which we will also show you. We'll end with the key takeaways and with the upcoming assignments, including the save the date for the final webinar. First, an overview of the cases, so ranging from 150 grams for a shaver up to 300 kilograms for a facade element. So quite a diversity. So we also advise you to take a look at the other examples on the Miro board to see what differences in results you get when analyzing different products. That's really nice to see. And also please comment on each other's work. That will really enhance your learning. So looking at the bill of materials, we've seen a variety. Overall, very nice results. Some questions about whether to best group per function, per functional module, or per material. Well, you can decide what works best for you. We mainly advise to group per function, like Juan Pablo did in this example. And when you only have, so what you can see here that he has many components with mixed materials. What you could do in this case, because it were only 8 components, is to split the heaviest mixed material component, which is the housing here, the casing, and split it in 2 with all the ABS parts in one module and the remainder of the parts in another. So you can easily say which of the 2, or in this case both, are recyclable because you consider them separately. So you've been analyzing the linear scenarios, and linear they were indeed, although there is some difference. Here you can see ranging from only 1% up to 30% circularity in the linear scenario. And as you can see in the third KPI, the yellow part refers to the use of either recycled content or renewable materials. So you can see a detail of that here. Also in that third circle, the light gray element refers to materials that you've defined as being recyclable. So they are recyclable, but in this scenario, not already being recycled, or no recycled material is being used. So it gives you an idea of the optimization that you could already do without having to change material use. A nice question of Ewald considered the difference between recyclable and using recycled content. Very good question. The first one refers to material property. So a material is considered recyclable if you could use it again at the same quality level, for a similar quality application. Whereas recycled content refers to the actual percentage of recycled material that is being used in that part or in that material. We've also had questions like how to find this material properties, and that's not always that easy. The best thing to do is to really ask your supplier, and hopefully they'll have that data. And it's also important that they know that you find it important to know this data, so they will hand it to you. Hopefully, if they don't have it now, they will retrieve it in future. We see this as a trend of being supplied more and more often. If you don't have that data, what you could do is use our rough guidelines from our experience. And also what we use is the Granta EduPack database. This is an extensive material database. It's not for free, but if you want to know quite frequently different material data, that is a database you could acquire. But in general, you could say metals already contain about 40% recycled content because there's a business case in that. However, I think it was Fieke that commented that some extrusion profiles of aluminum, for instance, contain only 12% recycled content. So this is a rough guideline, and preferably you ask your supplier. For plastics, thermoplastic plastics are recyclable, but generally they contain 0% recycled content, unfortunately. Thermoset plastics and composites in general are not recyclable. They can contain some recycled content, but mainly this is filler material, so not fit for the circular economy. And lastly, components with mixed materials will generally not be recycled, or only partially, because all the different materials are fixed together. And of course you have experience with this from your disassembly of the product, right? And sometimes they're partly recycled. So for instance, an electricity cable, the copper, highly valuable, will be recovered, and the plastic is lost in the recycling process. So this is all about circularity and recycled content, but of course we also had the value capture part of this analysis. And some of you, like Remco and Juan, already showed the screenshot with the euros, showing how much money is going to waste in the linear scenario. And of course, that's the economy part of the circular economy. Sandra asked some questions about this. Thank you for that. One was about how to deal with assembly costs. And this is more advanced level modeling with the costs. Typically, the assembly cost is where you put the costs for assembling all the different modules together into a product. If you want to have a more detailed analysis, you can also include the assembly costs within the module. And there's two different options. So either you can include them within the manufacturing costs of the module, or you can include them in the overall assembly costs. This latter option is best when you think the module will be disassembled in remanufacturing, because then that value is not captured when remanufacturing the product. So that's why you then add it there. Another question was about the sales costs. This doesn't include the profit margin. It's really about all the costs together will add up to the total costs that you're making to manufacture a product. So not a profit margin, but for instance, marketing costs. And the reason why we have this separate is that this in the tool, these are all the costs that are not embedded within the product. So if you're collecting the product, these costs will not be captured. So they will not be feeding into the value hill. So you would have to add them again each time you cycle the product. So I hope this makes things clearer. Now for the key takeaways. So what we've already seen, even in a linear scenario, there's typically some circularity from the use of recycled materials. So you can also play with that in your circular scenario. On the input side, can you already use recycled content, or can you increase the amount of recycled materials that you're using? So you don't have to change anything on the output side. So that's a quick win. And for the remainder of the scenarios, what we advise you to do is think back also of the disassembly process. What design changes would be needed in your product to make the circular scenario work? So refurbishment, remanufacturing, or closed loop recycling. So really think of the changes and also the changes in business model that would be needed to capture that value. Yeah, so these are the key takeaways. Next week, you have to finalize assignment number 9 and 10. Deadline is December 5th. So Sinterklaas in the Netherlands. So you may want to finish sooner. Also, we have a preliminary date, or not preliminary. We've set the date for the final webinar. So that's December 14th. So we hope you can make it and see you then. Good luck with the assignments.